Okay, and welcome everybody to another IATiP short interview with Joe O'Mahony from Waterford IT. So Joe, would you mind introducing yourself and your background, please?
Hello, I'm a lecturer in WIT in the School of Engineering, and I'm working on a fairly exciting project called STREAM, Sensor Technologies for Remote Environmental Aquatic Monitoring, which kind of brings together a lot of my background research, which would have been in printed electronics and in optoelectronics. So what we're looking to do is to develop sensors for remote environmental monitoring of the, I suppose, shellfish producing areas in the southeast of Ireland and West Wales. So my own personal background has been, my PhD is in physics and has been largely developing nanotech solutions for diagnostic sensing. And we're kind of extending that into STREAM to come up with some novel, innovative solutions for monitoring your marine waters.
Great, okay. So it's Interreg funded, yeah?
Yes,
right?
the STREAM project is an Ireland Wales funded initiative. It's a 5.4 million project that includes partners from Waterford Institute of Technology, Cork Institute of Technology, and Swansea University. I suppose the project is extremely interdisciplinary, where we're bringing in, I suppose, all stakeholders within the two regions to come up with a unified solution for efficient monitoring of the marine environment. One of the key areas that we're kind of very keen on is trying to assess the future impacts of climate change on the estuarine productive areas in Southeast Ireland and West Wales.
Okay, so in terms of what you've done with the project so far, would you mind talking about the innovation, so what you've done, where it's going, that sort of thing?
Yeah, one of the key points in the project is to look at printed sensors. So our colleagues in Swansea University and the Welsh Centre for Printing and Coating have been working extensively over the last maybe 12 months on the development of printed sensing solutions. So in that sort of context, we're replacing your traditional sensor with something that can be mass produced very, very quickly, that would have a similar lifetime to your standard sensor, but at a cost that would be a fraction of your standard sensory components. Now, the sensor head itself is kind of fairly basic. It's actually linking the electronics to that sensor head, and that's where the costs can soar quite considerably, and especially when you start adding your communications systems as well. So what we've been doing in Waterford has been, we've been working with a lot of different technologies in order to read those sensors. And some of the technologies that we've been working on have been produced by, you know, kind of, I suppose, major multinational companies, such as, say, Analog Devices here in Ireland, who have been very, very helpful to us in the project as well. And we're integrating the printed sensors with some of their technologies as well to come up with a very, very efficient solution for the marine monitoring. The sensors are currently at a very basic stage of development, but they are working, some of them anyway. And we're looking now to move those towards Swansea Centre for Sustainable Aquaculture Research for testing in a mesocosm environment to see that they perform as expected.
Okay, so excuse my ignorance, but when you say printed, do you mean 3D printed?
No, just a 2-layer print, basically printing electrodes with different polymer films. So for example, say a naphthalene layer would allow the chloride ion to migrate through between two conductive electrodes, and you would have a carbon sensor at the back end to detect your conductivity. So it's, yeah, I mean, also we could be printing semiconductors. You know, different polymers are semiconducting, so we can actually print our semiconductors as well. So again, in terms of pH sensors as well, you're just taking your standard electrode and you're just printing it down rather than, you know, I suppose using a liquid cell.
Okay, so why is this of relevance to Irish aquaculture, please?
In terms of the Irish aquaculture industry, you know, the efficient monitoring of the waters, you know, is going to guarantee cleanliness. I'd just like to add, all of these sensors will be benchmarked against the current state-of-the-art systems, and we are actually in the process of rolling out state-of-the-art systems into our test sites at the moment, which we've signed collaborative agreements with Wexford County Council at this stage, who have been extremely helpful to us. And we're putting in the state-of-the-art sensor systems in there that will continuously monitor the waters and provide that to our stream portal. So those sensors will detect like temperature, conductivity, salinity, total dissolved solids, total algae, chlorophyll, dissolved oxygen, fluorescence, dissolved organic matter, and also the nitrate in the waters. So, and they'll be streaming live from Bannow Bay and also from Wexford Harbour. So again, those two test sites will also be used then to benchmark to find stream sensors when they're deployed. We're also developing our own optical sensors as well. So those optical sensors will be, hopefully, when integrated with the printed sensors, will be providing the same information at a fraction of the cost, but at the same standard of accuracy and repeatability. So in terms of actually the Irish aquaculture industry, we hopefully will have, at the end of the project, a very, very quick solution to roll out into nearly all aquaculture producing sites in the southeast. So thereby we're just going to provide an extra level of protection to the waterways, but also we're going to gather a lot of information in relation to the effects of climate on the estuarine environment. So as climate change, I suppose in some cases can be advantageous to us, but look, everybody knows climate change is not a good thing, okay? So what we want to try and do is determine what the true impact of climate change is going to be on the marine waters. And we have people in Swansea University's CSAR who will be doing the actual modelling based on the sensory outputs from the environment. So therefore we should be able to come up with a toolkit for the aquaculture industry in order to better protect themselves from the impacts of climate change. And that would be the ultimate aim of the project.
Excellent. Okay, so you mentioned cost reduction being a major element. What kind of cost reduction are we looking at, or what's the aim?
Well, each of the sensor test sites that we're establishing is going to cost about €50,000 each. Okay, we're developing right now in Ireland. We're developing 2 in Wexford and 1 in Waterford and Dungarvan. So in terms of the cost reduction that we're talking about maybe 5,000 to about 2,500 per test site when established, which is a fairly significant reduction in costs. Supplementing all the information as well, what we're generating are going to be approximately 6 weather stations rolled across the coast as well that will provide complete weather information and also predictability of weather coming across as well to provide an early warning system. We're also developing, the group in CIT are developing a smart pumping system as well to test harmful algal blooms for presence of shellfish toxins. We ourselves are developing an anaplasmonic sensor, or very advanced optical photonic sensor for detection of those toxins on the smart pump system. So in terms of actually a comprehensive set of solutions for the aquaculture industry, if we hit maybe 30%, 40% of our targets, it should be a very, very substantial impact on the aquaculture industry in the southeast of Ireland.
Excellent. It sounds very impressive. So what's happening with the data? So what's next? What's happening with the data?
Yeah, well, we hope to start streaming live in the next maybe 6 weeks once the test sites are fully functional, and they will be available directly through our website. We'll also be on a live portal, and hopefully there will be a web app as well that should be downloadable in time. So that should provide live information to the producer in relation to the quality of the waters that they're actually producing in. So the next stage, once deployed, is to actually get that data live. We'll also make the data freely available to anybody who wishes to use it. So if anybody wishes to take that data and carry out their own models or their own predictions, then they're perfectly entitled to do that. It's freely available, publicly accessible. But we will be testing that data through grab samples as well, just to ensure the accuracy of that data at all times.
Great. Okay. Could you just run quickly through where the test sites are again, please?
Yeah, the first test site is going to be on the Cork River, just feeding into Bannow Bay, and that's really just to get the depth of the water there. It's very, very shallow in Bannow Bay, so it's not suitable for putting in the sand. However, our own sensors are going to have a much shorter profile, so we should be able to get something and keep it on the water in Bannow Bay as well later on in the project. The other test site will be in Wexford Harbour, and it's just going to be right at the tourist office in Wexford Harbour on the marina there. So look out for the kiosks when they go up. And the third site will be in Dungarvan Harbour So that's actually going to be in collaboration with Bord Iascaigh.
Oh, very good.
So, we are bringing all stakeholders into this project because, look, we see this as a public good project, and we want to make sure that what we do is actually going to have maximum impact for all producers and all users of the data as well.
Okay, so my next question was, how do people find out more? But so what's the aspiration with the kiosks? Would people be able to walk in and see the data live?
No, the kiosks will just house our equipment, but
Right.
the kiosk, we will have an information point as well. So there will be full information on the size of the kiosk, but they can actually access our website, which will be it's marinestream.eu.
Mm-hmm.
You should be able to access the information from the website as we go forward. We'll also be sending out regular tweets, and we'll be tweeting out data as well. So hopefully they can follow us at Ireland Wales is our Twitter handle, so they can follow us there as well.
Very good. And so that should all be up and running by December, hopefully.
Oh, hopefully. Fingers crossed.
Yeah.
Yeah, I think lockdown has slowed us a little bit, but we are working through lockdown.
Excellent. That's fantastic news. Was there anything else that you'd like to add?
No, I'm just looking forward to maybe come back and discussing it with you as we move further along the project.
Excellent. Well, congratulations. It sounds like it's going to achieve many, many things. So hopefully it all goes well.
Thank you, Georgia.
That's great. Thank you very much indeed.
Thanks.
Thanks. Bye.